RCHUB International Foundation for Research and Education, and ISO certified.
So, okay, I hope you have remembered what I taught yesterday, because that is the fundamental, okay, with respect to statistics and with respect to SPSS. So today we are going to learn three important aspects. That is how to perform the fundamental analysis and how to generate a graph. And we are also going to see the chi-square test and correspondence analysis. Okay, so let me share my entire screen. So everyone, please mute yourself. Is my entire screen visible?
Yes, sir.
Okay, ma. So this is the questionnaire we have seen yesterday. So I have typed all the questionnaire into the SPSS, and I hope you remembered what I taught yesterday. That is how to feed the data into SPSS. So the questionnaire and its corresponding options will be typed in the variable view, and its data set will be copy pasted in the data view after scrutinizing and cleansing. So now we are going to perform a fundamental analysis. So we know for every questionnaire there will be a demographic profile of a respondent. So let us perform a simple percentage analysis for the demographic profile. If you take our questionnaire, we have 6 demographic profile. You see, these are the 6 demographic profile. That is, D1 is gender, D2 is age, marital status, educational qualification, income level, and total experience. And whereas it is for this, in order to identify this as a demographic question, I have made the name as D1, D2, D3, D4, D5, and D6. Okay. Excuse me.
Yes, sir.
So now let us start performing a simple percentage analysis. So in order to perform a simple percentage analysis using SPSS, what you have to do is that you need to click on the Analyze tab. Click on the Analyze tab, and there are two ways to generate a frequency to do a descriptive statistics. Now let's perform the frequency. Now let us perform the percentage analysis. So go to descriptive statistics. Click on the frequencies. Click on the frequencies to generate the demographic profile simple percentage analysis. So now what you're going to do is that once you have clicked the frequency, it will be asking for what all the questions you wanted to do the percentage analysis. So we want 6 demographic questions, right? That is gender, age, marital status, education qualification, income level, and total experience. If you have confusion and if you cannot view the entire question like this, and if you know the exact naming, you can also change to that view also. Just simply right click, display as variable names. Now I will be exactly getting as D1, D2, D3, D4, D5, D6. That is the names what I have given. So now I exactly know D1 to D6 is my demographic question. So I'm going to select D1, D2, D3, D4, D5, D6. And I'm going to analyze or perform the simple percentage analysis for only these 6 variables. So I'm going to move those into the analysis variable. Then what I'm going to do is that I'm going to click OK. You see, now we got the simple percentage analysis. So you see, this is simple percentage analysis, which means with respect to IT industry, majority of the respondents, 73.6% of the respondents belongs to male and 26.4% are female. And among the 462 IT employees, 340 are male and 132 is female respectively. Similarly, with respect to age category, majority of the respondents belong to the age category between 26 to 35 because it alone attains a 40 percentage. And the next important category is 20 to 25, which is 31.6%. And similarly, it goes on. So this is how you need to perform a simple percentage analysis. So let me repeat, in order to perform a simple percentage analysis, click on Analyze, go to Descriptive Statistics, click on Frequencies. In Frequencies, you will be asked what are the questions you wanted to, for which you wanted to do percentage analysis. Select the question one by one or simply select Shift Down and then select the entire questions and then you click OK, you will be getting the frequency table. So this is how you need to perform a simple percentage analysis. In case if you wanted to generate a graph, if you wanted to generate a graph, instead of you viewing through the table, if you want to generate a graph, that is also available. In order to generate a graph, what you have to do is that you once again go to Analyze, go to Descriptive Statistics, click on the frequencies, and here once you will be seeing this window, right? In this window, in the side box, you will be having option called as chart. Click on this chart mark. Once you have clicked, you will be asked what kind of chart you want. You either click on the bar chart or the pie chart. For simple, if you're going to deal with only one categorical data, then pie chart or bar chart, okay, anything can be used. But the pie chart usually generally represents everything in the terms of percentage. And if you wanted to show everything in terms of numericals, at that point of time, you need to use the bar chart. So the important aspect is that only if you wanted to display one particular variable in terms of percentage, use pie chart or else use bar chart. So now let me do this by pie chart. I'm going to click OK. Now, if you take a close look, it will take some time. Yeah. Now we got the output. You see, with respect to gender, 70%, almost 70% are male. You see the blue color and green color. Similarly, if you want to display everything in terms of bar chart, that is also once again available. So click on the Analyze tab, go to Descriptive Statistics, Frequencies, and instead of pie chart, you can click the bar chart, put it in terms of frequencies, and click OK. Now you will be getting everything in terms of bar chart. You see, from bar chart, we can easily understand, right? So majority are male and less are female. And similarly, with respect to age category, majority are 26 to 35, followed by 20 to 25. And with respect to marital status, majority of them are unmarried. Education qualification is UG. And their income level is between 26 to 35 or 36 to 45. And total number of experience is either 1 to 5 years or 6 to 7 years. So this is how you have to perform a simple percentage analysis. So now, in case if you wanted to compare two variables, yesterday a student asked, right? So if there are two categorical data, what kind of analysis can be done? So I told we can perform, if there are two categorical data, we need to perform chi-square statistics. But in order to perform a chi-square statistics, there is a condition. That is, all the cells has to be having the value greater than 5. So that's the rule of thumb. So prior before that, we need to perform a cross tabulation. Now, let me teach you how to perform a cross tabulation using SPSS with two categorical data. So, do you have any doubt in this? Is everything clear? Is everything clear?
Yes, sir. Clear, sir.
So now let us do using two categorical data. So let us compare two things. What question we can see? Gender. Oh, no, no, no. Yeah, education qualification and income level. Let us compare education qualification and income level. So in order to do this cross tabulation, what you have to do is that you need to click analyze. You need to go to descriptive statistics once again. So you need to click the cross tabs. Click on the cross tabs. So you will be getting this kind of window. Did you see? It will be asking what will be the row and what will be the column. So you can let us choose yeah, income level as a row and education qualification as a column. This can even be interchangeably used. Now that's not an issue. And it will be asking you whether do you want to display the bar chart, the clustered bar chart. If you want, you can also check box this. Okay, now let me click OK. You see, now we got the output. Now we got the output. So you see, majority, yeah, uh, majority of the UG students are getting, yeah, yeah, irrespective of the UG students or PG students, majority of them or even professional degrees, they are getting the income level between 26 to 35 or 36 to 45. This is majority, 213 and 190. Let us see in the chart. Yes, it's once again same. Okay. So this is how you see two categorical data are represented in a single table. This is what is called as cross tabulation. This is what is called as cross tabulation. So let me repeat once again how to perform this cross tabulation. Click on analyze, go to descriptive statistics and click on the cross tabs and select the variable, select the categorical data. You see, the nominal data with respect to SPSS. You see three circles. So I have choose the income level and education qualification. And then if you want chart, you can check box or else no need. And then I'm going to click OK. So now I got the output. So this is how you need to perform cross tabulation using SPSS. So if you wanted to compare multiple cross tabulation at a single stage, that is also possible. Say for example, go to cross tab for apart from income level with respect to education qualification and total number of experience. And let us consider, yeah, let me consider this question also. Now I'll be getting three tables. Income with education level, income with total experience, income with frequently. In one stretch, I will be getting all the three result. You see, in one stretch, we got all the three result, all the three cross tabulation. First tabulation, income level with education. Second tabulation with total experience. And third is the how frequently training program is organized. So everything it came out well. So this is how you need to do a simple percentage analysis and cross tabulation with the categorical data. Is everything clear, ma? And this is how you need to generate a chart, the pie chart or the bar chart or a cluster bar chart. So till now, is everything clear?
Yes, sir.
So yesterday a student also asked, sir, when should we use the descriptive statistics, mean, median, mode? So now I will teach you how to use this mean, median, mode. Okay. So this is called as a descriptive statistics. This is what is called as descriptive statistics. Okay. Now I will teach you how to do the descriptive statistics. So this is our data set. Now, once again, we have entered the data set. Okay. So in the data set, let us see. Yeah. Let us consider this question. Let us consider Okay. This question. The company provides adequate training and resources to enhance the employee performance. This question belongs to PG1, right? PG1. So now what I'm going to do is that I'm going to click in order to do the descriptive statistics, that is in order to perform mean, median, mode, I'm going to click analyze, go to descriptive statistics. Under the descriptive statistics, there is another tab called as descriptives. You can either
बीच में लगा हम भूल जाएंगे
please mute yourself, ma. A technical team. Okay. So descriptives, you can do both the things, ma. You can also do descriptive statistics using descriptives or frequencies. Let me teach you one by one. Let us start from the frequency itself, which we have seen in the very first or very beginning itself. So click on the frequency. In the frequency, select the particular variable, ma. What is that particular variable? That is PG1, right? Let us see where is that PG1. Yeah, it's here, PG1. Once this variable is selected, now I'm going to perform the descriptive statistics. How? Click on the statistic tab here. If you click the statistic tab, it will be asking you what all the descriptive statistics you want. You may check box mean, median, mode, and if you want skewness, kurtosis, standard deviation, maximum value, minimum value, range, variance, okay, everything. But for this particular question, everything will not be meaningful. I tell you why. Okay. I'm going to click OK. And then I'm going to click OK once again. Now you see, we got the output. So now I will teach you what this mean, median, mode are. Is my Word document visible, ma?
Yes, sir.
Is my okay.
Visible. Yes.
Okay, so let me increase the font size so that it will be okay. First, let us come to mean. Mean means average value. Average value. Say for example, if there are five respondents, uh, first respondent is highly satisfied with your product. The second respondent is satisfied with your product, and your third respondent is neither satisfied nor dissatisfied. So the first respondents told 5 out of 5. 5 out of 5 mark. The second respondents told only 4 marks and the third respondents give only 3 marks for your product. So what will be the average? That is 5 plus 4 plus 3 divided by 3, right? So that is what is 4. So which means this is what is mean value. Mean value is nothing but the average value. So this you have to remember. Then comes median. Median is nothing but the middle value. Say, for example, you have 10 vehicles. 10 vehicles in front of you to check the mileage. And instead of checking the mileage of each and every vehicle, say for example, if I am given an opportunity to check the mileage of all the 10 vehicles, I am a little bit lazy. So what I do is that I will pick the vehicle which is in the middle. I will check the mileage and I will assume that it is the mileage of all the 10 vehicles. That is what is called as median. Median is middle value. Median is middle value. And mode. Mode is nothing but most repeated value. The mode is nothing but the most repeated value. And skewness, this is also very important, ma. But majority of the time the scholar leaves this thing. It is a measure of flatness. And there is another thing called as kurtosis. We call it as kurtosis. Okay. So it is measure of peakness. Okay. So these are the fundamental things. And there is something called a standard deviation. It is just peak. There is something called as peakness, there standard deviation. Everything is derived from only all these three things. Standard deviation is how far it is deviating from the middle value or the mean value. That is what is called a standard deviation. And square is variance. So everything is statistically relevant, ma. Okay. So now let's get into this particular thing. So here mean is 4.2965, which means what? Majority of the respondents have either selected 4 as a value or 5 as a value, which means they are saying that the company provides adequate training and resources to enhance the employee performance. Sorry. So for this particular question, they have either selected 4 as an option or 5 as an option. 4 is nothing but agree. 5 is strongly agree. That's why the average value is around 4.29. Have you understood, ma? That's why the average value is 4.29. Then we have the median. What is median? Median, as I stated, is middle value. So median is the middle value. Say middle value means if there is 462 respondents means 231. Who is 231? Median is the middle value. So that is the respondents after sorting everything from low to high, the 231 respondent will be considered as a median. That I will teach you in the analytical data. And mode is a most repeated value, which means majority of the respondents. What is mode? Most repeated value, which means most of the respondents have chosen the value 5. What is 5? The option 5 is strongly agree. The option 5 is strongly agree. So that's why strongly agree. So from this, we can understand that on an average, the respondent says that on an average, respondents either agree or strongly agree. That's why it's 4.29. That the company provides adequate training and resources to enhance employee performance. And most of the employees says that they are been providing training and resources. That is why most repeated, they strongly agree. And standard deviation is 0.859. That is from the mean value. That is the middle value. The value is getting deviated by 0.859. That is either it is 3 or 5. That is 0.8 means 4.2 means 0.8 means either 5 or 3 point something 3.4 something like that. So that's how the value is getting deviated. And skewness is a measure of flatness. I told you, right? If the skewness is between -3 to +3, it's almost flat. It's not there is no, but in case if it is greater than +3 or lesser than -3, then there is a huge flatness among one side. There is a skewness along one side. That is what is called as skewness. And kurtosis is a measure of peakness. Peakness in the sense if it is greater than 3, which means most of the values are high. That is either 4 or 5. That's why it's 3.529, greater than 3. So that is what it is. So let me give you a best example for this skewness, ma. Say for example, I'm a teacher for you all, and I'm going to conduct a test. So if I given a very simple questions, what do you do? Majority of the students will be getting more marks in the sense between 70 to 90 or 95. Majority will be get scoring will be, let me open the print. Yeah. So if this is normally distributed line, if I give the question very easy, what happens is majority will be getting more marks. That is 0 mark, less than 30 will be very, very less. Majority of the respondents will be getting either 95 marks to more than 30 marks, more than 30 to 95 marks. But in case if I given, this is what is called a skewness along the right side. In case if I given the very tough question paper, what happens? Majority of the respondents will be getting the marks less than 60, and very few will be getting marks greater than 60. You see? So this will be the distribution. Majority of the curve will be here. So this is what is called a skewness. Okay. Now I hope you are understood the concept. Okay. So now we can perform descriptive statistics for the Likert scale. But this descriptive statistics, that is mean, median, mode, is very sensible or very, very logical one for secondary data only. So I have also secondary data. Ma. Let me open that data set. Okay. Okay. Is this data set visible, ma? Is this data set visible?
Yes, sir.
Yes, sir. Yes, sir.
Okay, ma. So we have three data. One is agriculture export value in terms of crore rupees. And second is agriculture product export in terms of metric ton. One is measured in terms of rupees and another is measured in terms of quantity, that is metric ton. So this is the data from 2006 to 2022. So now let's perform descriptive statistics. So how to perform the descriptive statistics? Click on Analyze tab, go to Descriptive Statistics, click on the frequencies. Now select the variable. Can we select? Let me select one variable. Let me select rupees. Okay. Go to the statistics. Now I'm going to select mean, median, mode, sum, standard deviation, maximum value, minimum value, variance, range, skewness, kurtosis. Now you will see all logical things coming into place. Now let me click continue. Now I'm going to click OK. So yeah, now we got the output. Okay, so this is the output. What is mean? Which means we are exporting agricultural processed product on an average of 6,405 crore rupees worth. On an average, we are exporting agricultural product. Median is the middle value. Median is middle value. Let me open Excel also, so that you may better able to understand. Because okay. So let us copy this particular values here. Okay, now we have copied these values. Okay. So don't look at the output here. Now hereafter, let us see the output here in the Excel sheet. Okay. And let me also copy paste the data set for better reference. Okay. Is my Excel visible, ma? Let me increase the font size so that it will be a little bit visible for you. Okay, ma. Is everything visible?
Yes, sir.
Yes, sir.
So now what I'm going to do is that now I'm going to calculate. What I said, mean is nothing but average value. Average value. So let's find out. So now let's find out. So I'm going to sum everything, sum all the rupees. Okay, divided by how much values? 1 to 17 years, right? 17 years divided by 17. You see, now I'm getting the value of 64052.2, which is equivalent to this value, right? The same, right? So this is what is mean. Mean is nothing but the average value. Now let's calculate the median. Now let's calculate the median. Median is, as I stated before, is the middle value. So how to measure the middle value? First, we need to sort all the values and then finally we need to calculate the middle value. So let's sort all these values, ma'am. Sort from low to high. Okay, smallest to highest. Let me expand this selection. Okay. So we have 17 numbers, 17 years. So what is the middle value? If there is 17 years, what is the middle value? Divided by 2. 8th year is the middle value. 8th and 9th year, that is 8.5. 8th and 9th year is the middle value. That is 1, 2, 3, 4, 5, 6, 7, 8. This 8th value. What is the 8th value? 9, 3, 6.47. Okay. And another value is, so 9, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 8, 7, 6, 5. You see, this 9th value is the center value. You see, 9th value is the center value. Because from the, did you understand? The 9th value is the center value. So if we take 17 as a value, the 9th value will be in the middle. Prior before that, there will be 8 values. After that, there will be 8 values. So the median is the middle value. What is the middle value here? Median is the a value 8023.91. Let's check whether this value is the measured value. Yeah, you see, the median is 8023. So what is median? Median is nothing but the middle value. Median is nothing but the middle value. Now let's check the most repeated value. Mode. Mode is most repeated value. Generally, the SPSS has a problem with this. In case if there is no, let me delete this. Let me arrange once again in the proper order. Okay. So in case if there is no mode, no repeated value, it will generally display the first value. That you will be seeing a alphabet called as A, which means it says that it is not exactly the value that cannot be considered, but that's the first value. In case if there is most, here there is no most repeated value. All the values are different. See, there is no value repeated. So most repeated value is null. So then comes the standard deviation. So standard deviation, as I stated before, is the value, how far the value is getting deviated from the middle value. How far the value is getting deviated from the middle value. So now with respect to secondary data, everything makes sense, right? So it will tell that if in 2023, sorry, in 2023, with 6405 as a mean value, the value could deviate from 3229, either plus or minus. So that's how the standard deviation works. And skewness is 0.781, which means here let us draw the graph. Let us draw the graph for this. You see, it's increasing linearly. There is no peak. Like in share, you may able to see that there is sometimes peak and sometimes very big downfall. That's called as volatility. Like that, we don't have. It's almost goes flatly in a linear way. So that's why we see there is no skewness at all. Skewness and kurtosis are almost null. And range is nothing but the maximum value minus minimum value. If you take a close look, the maximum value is 11465. When during 2022, we have exported a huge agriculture products to other countries, and its value is 11,465.65 crore rupees worth. And at minimum, we have exported during the year 2006, that is 48.12. So overall sum is nothing but the sum of all the values, which means on for 17 years, we have exported the following. We have exported worth 1,08,888.2 crore rupees worth agricultural products to other countries. You see, now for the secondary data, this entire descriptive statistics have become very meaningful. Do you understand? Ma, is the thing clear, ma?
Yes, sir.
Okay, so now let's move. I think we have a little more time. So let me try to complete even the chi-square test, because tomorrow we'll be looking at other types of t-test, correlation, regression. Okay, so yeah, in order to perform the chi-square test, I told you, right? In order to perform the chi-square statistics, what are the important requirement? What are the important requirement? The categorical. If the variable one and variable 2 both are categorical in nature, at that point of time we will be first we will be doing cross tabulation. If in case in cross tabulation, if all the values or all the cells are having values greater than 5, then we will be performing chi-square statistics. Because many times I see some of the scholars, even without even fulfilling this criteria, perform chi-square statistics, and in the end of the table, you will be seeing nearly 20% or 30% of the cells doesn't fulfill the criteria. You should not do that, ma. You should first make sure that all the cells are filled with some number, some numerical values. And only then we need to perform the chi-square statistics. Okay. So let us perform the chi-square statistics once again for the same variable for better understanding. let us consider income level and education itself. Okay, so in order to perform this chi-square statistics, what you have to do is that you need to click analyze. You need to go to descriptive statistics. In descriptive statistics, click on cross tabulation. Since chi-square statistics is an extended version of cross tabulation, go to the statistics. Go to the statistics. Click on chi-square and phi and Kramer's value. This is the best statistics. There are various techniques to calculate the chi-square statistics, and this will show you the better association result. Okay, these are different techniques. That's it. Okay, click on continue. In the cells, it is the observed box is more than enough, but we know when it comes to chi-square, if you do manually, we will calculate the observed reading and the expected reading. If you want, you can check box the expected, or else you can go on with the observed cell. Okay, so I'm not going to use the expected, but okay, let me check box the expected cell also. Now I'm going to click OK. Yeah, you see, now we got the output. That is 23 is expected count, but the original count is only 15. For this 9, okay, this is fulfilled. For this, it's only 1, but 10 is there. Okay, great. Let's see how to interpret the chi-square statistics. In order to interpret the chi-square statistics, what you have to do is that you need to look at the chi-square, the Pearson chi-square significance value. You see this 2 cells, that is 16.7% of the cells has the count less than 5. So which means the minimum expected count is 1.41. This itself says that your chi-square statistics is not much reliable, but here it is acceptable mark, because if it is less than 20%, it is acceptable. If your cells, that is, there are only 2 cells with those kind of values. If it is greater than 20%, your chi-square statistics cannot be considered. This is okay. Less than 20%. For your information. So, okay, let me explain you how to interpret this chi-square statistics. First, using the cross tabulation itself, you can say the what this analysis is all about. I think this expected count is clumsy. Actually, this is how we calculate, right? But actually, in practicality, we don't want that because it's already been calculated, right? So let me go to cross tab in the, yeah. Now let me click OK. Yeah, now I got the clear values. So you need to look at the cross tabulation. In cross tabulation, we could see that majority of the respondents were irrespective of the, yeah, with respect to UG and PG. This is how it works. Okay. Look at the Pearson chi-square significance value mark. That is, if the significance value is less than 0.05. If it is, please mute yourself. Yeah. If it's less than 0.05, then your null hypothesis is rejected. Say, for example, I will teach you in a very simplified way. Say you are a judge. And I am the lawyer. You are telling me that if you come with 5% evidence, 5% evidence means 0.05, right? If you come with 5% evidence, I will accept your case. You are a judge. You are telling me that if I come with 5% evidence, you will accept my case. Or else, if I am coming with less than 5% evidence, you will reject my case. So I am coming with 0% evidence. You see, 0.0000. Then what you will do? You will reject my case. And my name is null hypothesis. So what is null? Null means there is no significant association. There is no significant relationship. There is no significant difference. So here, the null hypothesis, there is no significant association is rejected because there is no evidence. 0.000, less than 0.05, which means there is significant association. There is significant association between the education qualification and income level. There is significant association between the education qualification and income level. So let us take a close look here. Let us take a close look here. If we take a close look, we could see that mostly the professional degree holders are either getting very less income or generally, majority of the respondents are getting the income range between 26 to 35 and 36 to 45. Okay, that sounds good. So with respect to which means there should be some association in the sense. Let's take a close look. Yeah, that's the thing. And here, because since the two cells are having less value, I think we are getting some deviated result. Let's go on with some other data, ma. It's generally association means significant association means income level with respect to particular variable is high, and for this particular variable some other thing is high. That is what is called as association. Since we have some values less than since the cells are having less value than count 5, we are getting this some deviated result. So that's why I used to say, generally always see to it that all your cells are filled with numbers, and especially more than the expected count. Only then you will be getting a right result, or else you will be getting this kind of deviated result. Let us go on with some other data set, ma. So let me go on to the cross tab. Instead of education qualification, yeah, how frequently training is given. This data set is once again more worse. Okay, let's go on with some other data set because it has 20 cells, 4 cells, the values. Let me move on to gender. This is okay. This is okay. You see, we could clearly see that there is significant association, which means males are given more frequently. The trainings are given more frequently, whereas the females are it's like it's almost normally distributed. You see 21, 20, 28. Once again, frequently is high, but still 21, it's normally distributed. But for male, it's high. It's sometimes or frequently or always. This is the most highest value. Whereas 13, 15 or which means males are mostly given training, and females are it's not given. I mean, they are normally distributed. They are not much either given or not at all given. Like that it goes. So this is a significant association. So there is significant association between the training and the gender. So with respect to male, the trainings are more frequently or sometimes are always given. Whereas with respect to females, it's common or commonly distributed. So this is how you have to interpret, ma. So this is how you have to interpret. First, you need to look at the Pearson's chi-square value. If it is less than 0.05, your null hypothesis is rejected. So think of this story. You are the judge, I am the lawyer. If I come with 5% evidence, my case will be accepted. I am null hypothesis. It will be accepted. If I come with less than 5% as evidence, that is 0.05, less than 0.05, my case will be rejected. If I am rejected, what will be accepted? The alternative hypothesis. What is that? That is there is significant association. That is significant relationship. This is what is chi-square statistics. So what is this phi and Kramer value? So Pearson chi-square statistics is okay. What is this phi and Kramer value? The phi and Kramer value is nothing but it illustrates the level of association. That is 31.7% association between the frequency of training and the gender. That is 31.7% is the frequency of association between the frequency of training and the gender. This is how you have to interpret, ma. Is everything clear? Today I have three important things. One is the simple percentage analysis. Second, I have also taught you how to do the cross tabulation and how to generate the chart, that is bar chart, pie chart, and the cluster bar chart. And then I have also taught you how to perform the descriptive statistics, mean, median, mode, with respect to a Likert scale based question. Likert scale based question and how to interpret that. And also I have taught you how to do the descriptive statistics we use with the secondary data what we have and how to interpret that. And then I also have taught you how to do the chi-square statistics. Is everything clear, ma, in today's session? I think this is more than enough. I don't want to dump you. So tomorrow, be ready on time. Tomorrow we have many topics to get covered. So is everything clear?
Yes, sir.
Yeah. So do anyone have any doubts, ma? Please. Yeah. Sir, could you please explain the difference of these analysis and business analytics? So, when it comes to business analytics, ma, I tell you, when it comes to business analytics, we generally use a different software like Tableau, Power BI. Generally, every data are illustrated in terms of pictorial representation for decision making. This software, SPSS, provides all the result numerically. Actually, this is what the data analyst and data analysis done. After the data analysis only, the business analytics will comes into play. So business analytics is the end option. This is data analysis. This data analysis is common for social science studies, business studies, economic studies, and all aspects. And business analytics, it literally deals with only generating the graphs and the tables that used to depict to the directors and the managers for decision making. There is significant difference, ma. Generally, they don't understand numbers. They don't understand statistics. So they put everything in the terms of charts and bar graphs and other T charts, other types of charts, fishbone charts, so that they may easily able to understand and make decision. So that's the difference, ma. So anyone, any other question, ma? Standard deviation. Standard deviation, it's very simple, ma. Say, for example, once again, let's consider the Honda Activa itself. The Honda Activa, on an average, you have measured 10 mileage of the 10 vehicles, and it is found that on an average, it is giving a mileage of 36 kilometer per liter. 36 kilometer per liter. And what is the standard deviation is all about means, sometimes some of the vehicles are giving the mileage of 32. Some are giving the mileage of 38. So the standard deviation is, that is from 36, it's getting deviated either plus 2 or minus 2, right? So that is what is standard deviation. So either your value from the mean value, it will be 34 or 38. That is what is standard deviation. Standard deviation is how far the value is getting deviated from the mean value. In case if you are dealing with a Likert scale based question for less than 30 samples, at that point of time, you cannot consider the mean value. That point of time, you will be considering the middle value, that is median. It varies as per the study, ma. Is everything clear? Any other question? Yeah. Someone asked me the recordings, right? Yeah, yes, ma. This entire recordings will be distributed to you at the end of the session. Okay, I have made a concern with the technical team, and they also have stated that this entire recordings will be given to you. Okay, it will be having the moving PPT and everything in the form of video format. So don't worry, ma. Okay. So anyone, any other questions? Is today's session everything clear, ma? Do you have so no doubts, right? Or else, if you have any doubts, even with respect to your research, can you brief once the rejection and accepting the null hypothesis?
What?
Okay, ma. I told you, right? It's very simple, ma. I'm not just telling with respect to chi-square, with respect to anything. As I stated before, the
Okay,
first
sir.
and foremost is that, excuse me. Yeah. The first and foremost is that null hypothesis is, accepted or rejected is purely based on the significance value. The significance value. If the significance value is greater than 0.05, if the significance value is greater than 0.05, the null hypothesis, let me write it down. Is my entire screen visible, ma? Is my entire
Yes,
screen?
sir.
Yes, sir.
So this is a standard rule. Okay, you have to look at the significance. You have to look at the significance value. If the significance value is greater than 0.05, I told you, right? Then the null hypothesis is accepted. In case if the significance value is less than 0.05, then the null hypothesis is rejected. For this only, you remember the story, ma. Okay, the story is judge and lawyer. Judge and lawyer. Okay. Judge told the lawyer that you have to come with at least 5% evidence. At least 5% evidence. What is 5%? 5% is nothing but 0.05, right? You know, if you are bringing any case, you need to make sure that you bring with at least 5% evidence. See, so if I'm bringing 4% evidence, what the judge will do? He will reject my case. He will reject my case. If I'm bringing 0.4%, 4% evidence, my case will be rejected. See, judge is telling me, judge is telling me, that is, I am null hypothesis telling me that for any case to get accepted, you need to bring at least 5% as evidence. If you're not bringing 5% evidence, I won't be accepting you, I will be rejecting you. So if you take a close look here, I have brought 8, say for example, I have brought with an evidence of 16%. That is 0.16 is my significance value. What will do? The judge will accept my case. That is null hypothesis accepted. What is null hypothesis? The null hypothesis is nothing but there is no significant association or relationship or difference. So this is what the null hypothesis will say, right? There is no significant association, relationship, or difference. Very simple, ma. If the value is greater than 0.05, null hypothesis accepted. That is, what is null hypothesis? There is no significant association. There is no significant relationship. There is no significant difference. With respect to the chi-square statistics, both the data are categorical. We generally do this to identify whether significant association is there or not. So which means with respect to chi-square statistics, there is no significant association if the significance value is less than 0.05. If it is greater than 0.05, then the null hypothesis accept there is, sorry. If the value is less than 0.05, then my null hypothesis is rejected. Then I have to say there is significant association between the variable. In case if my null hypothesis is greater than 0.05, at that point of time, I have to say that the null hypothesis is accepted, there is no significant association. Is the thing clear, ma? Okay, so anyone, any doubt? So, okay, then thank you all. Tomorrow, everyone try to be present on time. So you'll be starting on time. We have lots and lots of topic to get covered. Thank you all, ma. We see. Take care. Bye.
Thank you, sir.
Thank you.
Sir.
Contact RCHUB International Foundation for Research and Education. WhatsApp 9888 231 231.